Way 70 continues our discussion about solutions, and it specifically addresses concentration. And please note that the concentration formula is given in the back of table T, and it corresponds to molarity. Whenever we need to find molarity, which is just the amount of substance in a particular solution, it's represented by moles of solute in liters of solution. Typically, the liters of solution is usually water, but it doesn't always have to be that. The solute is a substance being dissolved, and it's represented by moles. When it comes to these problems, please note that they will typically ask to solve for one of these and provide two of these values in the problem. So let's try some examples. What is the molarity of a solution that contains 0.500 moles of potassium nitrate dissolved in 0.500 liters of solution? Well, consider what's given, 0.5 moles and 0.5 liters, and it's asking for molarity. So all you have to do is plug in those values for moles of solute, which is 0.5, and liters of solution, which is also 0.5, and you get the answer 1, which is 1 molar. So answer choice 1 is correct. Which expression could represent the concentration of a solution? Note that that this is not correct. Note that the answer choice 2 is correct, molarity, and it's represented by a capital M. It is not 1 because G is represented by mass, milliliters represents volume, and moles represents amount. So the correct answer is actually 2, 3.5 molar, because that's what concentration is measured in. A sample of seawater is analyzed. The table below gives the concentration of some ions in the sample. Determine the number of moles of SO4 of sulfate ion in a 1400 liter sample of the seawater. Note that here 1400 liters of seawater is provided, and it wants to know the number of moles of sulfate ion given that the molarity of the sulfate ion is represented in this table below. We know that molarity is equal to 0.028, and we're given the volume of solution in liters, which is 1400. So all we have to do is plug in these values. Our unknown currently is the moles of solute, which is x, or is represented by x. So when we do this, all we have to do is cross multiply, and x is equal to 39 moles. 0.028 times 1400 will correspond to 39 moles. What is the molarity of 1.5 liters of an aqueous solution that contains 52 grams of lithium fluoride? Please note that for this, it gives you the gram formula mass. And in order to calculate molarity, you need moles of solute. So how do we get moles from grams and this gram formula mass? For this, you're going to have to utilize two formulas. The gram formula mass, which tells you that the moles is equal to the mass divided by the GFM. Please note that the GFM is already provided for you for this compound, so you need not calculate it by adding up the masses of each of these elements. So you're given a mass of 52 grams, and we find that the gram formula mass is 26. We know to get moles, we just take the mass divided by the GFM, and out pops 2 moles of lithium fluoride. To calculate molarity from that, we just have to take the moles of solute, which corresponds to 2 moles of lithium fluoride, and liters of solution, which it tells you in the problem is 1.5. So 2 divided by 1.5 gives you 1.3 molars, which is answer choice 1. So for this problem, you're given mass, and you need to find moles from that value using the GFM formula. And then once you have moles, you can plug that into the molarity formula, and out pops your concentration. The molarity of an aqueous solution of sodium chloride is defined as. Should you ever forget what molarity means, you can consult table T and the equation for concentration, and you know that molarity is equal to the moles of NaCl per liter of solution. And that is always the definition of molarity. That is always the formula. Moles of solute, which is a substance being dissolved, over liters of solution. Okay, so when it comes to this way, remember that molarity is equal to moles of solute divided by liters of solution, and that equation is provided for you on table T. Sometimes the problems will give you a mass, and you'll have to calculate moles from that. And the way you do that is by using the GFM formula provided here. Here. When given mass instead of moles, we take the mass divided by the GFM to get moles, and then plug in moles and divide it by liters in order to calculate molarity. Thank you for watching.